Really great to be presenting to such a vibrant open source community. And I'm really excited about some of the things that we're doing in partnership. My name is Jing. I'm the cloud go-to-market and partnerships leader for Memverge, and I'll be one of your presenters today. I'll pass it over to Hui so that he can introduce himself as well.
Hi, my name is Chen. So I'm a senior solution engineer working for Memverge, and we work very closely with this community and develop this new MMCloud plugin, and really love the job and want to see this take off. Thanks. Yeah, we have several members in this meeting as well. So Frank, YT, and Helen, can pass to Frank maybe.
Yeah, hi everyone. This is Franco. I'm the manager of support at Memverge, and I'm very glad to participate. And yeah, thank you.
And this is YT Lian. I'm the product manager from Memverge, based in California. Exciting to join this community. And I'll pass over to Helen.
Hi, my name is Helen, and I'm working in Memverge as a software engineer intern. So I'll be continue doing this Flyte plugin. Yeah, nice to meet everyone.
Great. David, should I kick things off?
I would say yes.
Sorry.
Okay.
Yeah, for sure.
Okay, great. So what we've prepared today is a few quick slides just to give everyone the background on our company, our product, and how it's integrating with Flyte. And then we'll keep the second half of the presentation as a demonstration segment where we have both a recording as well as some live show and tell that we've prepared. And please feel free to ask questions and yeah, just chime in at any given point if you've got things that you want to double click on. I want to make this as interactive as possible. So with that, I just want to start with basically why do we exist and what are some of the problems that we're aiming to address here at Memverge. And the first is really a skills shortage, which is multifaceted when it comes to cloud computing. There's all these different tools and technologies to learn that can be both used in the cloud as well as on-prem. And one of the things that we find is that most enterprise and also, especially we see this in the research institute and higher ed organizations, is there's just a general lack of deep cloud engineering and cloud DevOps skills. And that's one of the areas that we're focused on as a company. And because of that kind of lack of deep cloud skills, as people move to the cloud for all the different benefits that it brings, it's also really, really easy to both be sub-optimized and also to overspend. So then on the right, what we're also trying to address is one, at the same time helping developers, researchers, data scientists be able to take advantage of cloud compute resources more easily, and at the same time help them really quickly take advantage of ways to be cost optimized and also performance optimized when they're starting to use the cloud. And the way that we do all of that is through software that we've built that helps to automate different parts of using the cloud. And one of the really nice intersections that we've discovered as a product and as a company is that one of the areas we can help the most is to help automate as an extension of workflow managers like Flyte. And so you can think about Memory Machine Cloud, which is the name of our product, as a tool and also a automation platform in the cloud for containerized applications that you're trying to run. And one of the things that we distinctly help you do very quickly is to start using spot compute in different parts of your pipelines, your workflows, and even just individual applications. And we all know that when you start using the cloud, there's several hundred different computing choices. Just at the compute layer alone, each cloud offers in the hundreds of compute, sizes, machine types, and kind of fit for purpose, like compute optimized versus memory optimized versus general compute. You have so many choices. And one of the things that we also do is to help you quickly take advantage of the right compute options on the clouds. And so we started on AWS. We also now support GCP. And then in Asia, we support Ali Cloud and Baidu Cloud. So who's our typical end users? These would include developers, data scientists, and also we found a particularly strong niche with researchers, both in the university, higher ed, independent research institute, as well as in some of the biopharma spaces. And the kind of the 2 to 3 killer use cases is automating data pipelines, which many cases for us means just a chain of different batch computing steps or jobs that can sometimes take hours to even days because of just how much data or how computationally intensive they are. And also what we are really great for as well is interactive computing applications. So even just something as simple as a Jupyter or RStudio instance, or different programs that you've written in Python or R that you want to run on a regular basis or on a continuously running basis. So as an extension now with our plugin for Flyte, we offer a set of capabilities that before you would have had to essentially build your own stack to go and do. The first is we have something called Float, which is a way to automate the spin up and spin down, provisioning, deprovisioning, and monitoring of the cloud infrastructure. So you can think of Float as something that goes out, and using AWS as an example, it quickly goes and grabs all the compute that you need for a particular Flyte workload that you want to run. And then it monitors those workloads and completes them, and then gives those resources back to the cloud provider. And it can do that across a range of cloud computing options, and it can do that across different pricing tiers as well. So for example, on-demand compute versus spot compute. Once we are provisioning and monitoring those workloads, we can do three really interesting things. The first of which is we can spin up spot compute, and we can monitor and automatically checkpoint, recover, and migrate those workloads if and when the cloud provider is taking that spot VM back. And we all know that one of the benefits of using spot compute is that you can save up to, in some cases, 80 to 90% versus the on-demand price for the exact same machine. But then the drawback with each of the cloud providers is that you get between anywhere from 30 seconds as it pertains to Google Cloud and Azure, and AWS is a little bit more generous. They give you 2 whole minutes to basically take care of your workload before they are able to just take it away, even if you're not done. And so Spot Surfer is a really nice way to not have to start your batch jobs or rebuild your environments in the event that the cloud provider takes the VM away before your workload is complete. We have a way of doing this so that the memory state of the workload is captured and then automatically moved to another machine that we're spinning up for you with the Float capability. And then WaveWriter is a way for, especially for users who are bringing workloads from an on-premise environment into the cloud, to really quickly find the right set of cloud computing VMs so that you're not overspending by over provisioning, and that you're not under provisioned and then run into performance issues, or even just altogether run out of memory and kind of fail a workload and have to restart because of that. So WaveWriter takes the same checkpoint, restore, migration service, and it repurposes it so that it's focused on moving your workload to the right sized VM, either larger or smaller. And then WaveWriter is basically a way to continuously monitor all of those different Flyte tasks that are being executed by the Memory Machine Cloud service. So I'll pause there just to see if there's any questions before moving into our integration. Okay. I'm not sure if not sure if there was any questions, but I'll keep going. Just feel free to chime in if you do.
Jing, I might have, this is Martin, I'm with the Union. I just have one question for getting onto the Memory Machine Cloud. Is there a free tier to try this stuff and for people watching this?
Yes. Yeah, there's a free tier that we offer, and we'll be updating the details this month, but essentially how it works is you get 500 free core hours each and every month, and you get all of these features. So you don't have to upgrade to get something like Spot Surfer or WaveWriter. You get to see the entire platform, and you get to run different a fairly good amount of work before you kind of hit that 500 core hours threshold. And yeah, and then we're also obviously interested in working with different folks who may need to test larger workloads as well on the platform.
Fantastic.
We provide a free trial as well of the other tiers. Okay, great. So how exactly does it work with Flyte? For this part of the presentation, I'm going to transition it over to Hui, and Hui, feel free to feel free to take it away.
Yeah, thanks, Jing. So, yeah, the Memory Machine Cloud plugin for Flyte, as Jing said, allows the Flyte users to configure MMCloud as the computer environment for the execution of a Flyte workflows, right? So with the MMCloud as plugin at the computer environment, the Flyte user can choose leverage MMCloud features. For example, choose run the workflow on demand or on spot instances. Also can choose like a Wave Watcher to check how big the resources required to run the workflow to avoid over provisioning or under provisioning. All right. So how does it work? So basically, thanks to the beautiful framework established by Flyte, so we develop an agent called MMCloud agent that allows the user to submit a job on MMCloud through Flyte, like use the command like a PyFlyte run. So the MMCloud agent will call MMCloud task. So the task is just the simple form of the job running on the MMCloud. So the MMCloud task will take the configuration from the MMCloud config, which configs how the MMCloud task can be executed on the MMCloud. So, and we have some like extra options to allow the users, to config some like a migration policy, VM policy, or the resource requirements like a max CPUs, max memory, this kind of things. So eventually, the task will go through float submit, like we just talked about. This will submit a job to the MMCloud, and we have a lot of options to can specify the job, how this will be run. So with that said, we are going to run a demo here. So what I'm going to do here, we record a demo in a short, like a very short video. We are going to play that. Then I can run a live demo, and we'll show you how this works, and we'll show you how the option our MMCloud can help to provide insight to the jobs. Also can just adjust the resource utilization based on our features. So let me see. Can I be share something here?
Yeah, I should be able to share.
I just took the slides down.
Okay, so hold on.
Hi all.
Can you
I'm
guys
going
hear?
to quickly demonstrate the Memverge memory machine.
Can you guys hear the sound? Or
Yep,
everything's
yeah.
okay?
Mhm.
Yeah.
Yeah,
Okay.
we can hear the sound. And then the screen I see is on the left is the Memory Machine Cloud Ops Center login screen, and then on the right there's another side, so it's like a two-sided screen. Is that what you need?
Yeah. So did
Okay.
you see that video here? No.
Cloud plugin for Flyte. First,
Can you see that video? No.
Yes.
Oh
Looks
yes.
like-
Okay.
I
Okay,
think
cool.
I think the two screens is what Jing was saying is the video that he's showing.
Yeah.
you
Okay,
want to
cool.
set up Memory Machine Cloud, also known as MMCloud, as well as a Flyte.
Let me-
Hi all. I'm going to quickly demonstrate the Memverge Memory Machine Cloud plugin for Flyte. First, you want to set up Memory Machine Cloud, also known as MMCloud, as well as a Flyte deployment. Instructions for how to set up MMCloud can be found at docs.memverge.com. Before we log into MMCloud, we can quickly grab the float CLI binary, which we will need later for our agent deployment. We can interact directly with the Ops Center via the web CLI, but this is not useful for Flyte. We can also get the float binary after logging in. Here, we can see that we have no active jobs. To use MMCloud with Flyte, install Flyte plugins MMCloud using pip. I already have it installed. Also copy the float binary mentioned earlier to your agent deployment. I have already done this. I am using a sandbox deployment, so I will be running the agent service locally. This is the workflow we will be submitting to Flyte. Simply specify task config in each task decorator. It is based on the example workflow from Flyte's Getting Started page. We can register and run the workflow using PyFlyte Run. Registering the workflow can also be done using PyFlyte Register or PyFlyte Package and FlyteCTL Register. We can specify the image to use in the packaging or registration command. Alternatively, we can specify the container image for each task. Image spec can be used to build images. Refresh the Jobs tab in Ops Center to see our submitted tasks. Let's wait a bit for a task to complete. Click on the job to see its details. Here we can see the script that was submitted to the Ops Center. We can also find the standard error and the standard output of the job here. Additionally, there's a log of events so that you can know what's going on when your task is running. Wait for our workflow to finish. We can look at the S3 bucket contents to verify that our workflow has completed successfully.
Okay, that's it. So that's the demo video, and now I'm going to show you guys a live demo to how to do that. So give me 1 second. Let me share my screen. Okay, hold on. How do I get? How do I get rid of that? Oh, yeah. Can you guys see my screen?
Yeah.
Yeah.
It was
Yeah,
two
this is
windows,
one.
yeah.
So yeah, this is actually the demo, the example we took from Flyte's the website, which is like I think get the classic Y dataset, use the sklen. In this workflow, there are 3 steps. The first step is get the data. Second step is process data. And the last one is like build the training model, right? So this is the example we are running. So we need basically we start the a Flyte like agent service on the local port, which I already started. And we also need apply the configuration about the MMCloud address, username, password, and also some options like a CPU requirement, memory requirement, all these kind of things in that the MMCloud configuration. So basically, I already started that. So everything starts. So to run the job, we just use the PyFly run, like choose what the image you want to run, and then the Python example files, and how to run that. So with that running, okay, the job is running successfully, and now we are go back to basically our MMCloud to check that. You can see the job is passed to our MMCloud. And the first step is started, and we are initializing the job here. So basically, if you go to Flyte project, the dashboard, you can see there is a new project created, which is running this example. And you can see the first job is running the first node. And if you check the process, you can see there, this is a workflow, the 3 steps: get data, process data, and training model, right? So basically now is the first step is running, and you can see, you can check inputs, outputs from here. It takes some time for us to get the instance from AWS or any like cloud service provider. So that's take about 2 or 3 minutes to get the first step down. From our Ops Center, you can check the logs to see how this the job is the job status, right? So you can see we pick up the spot instance from a bunch of the candidates. So if you go to like if you before this is take some time. So actually, I this morning I already run this demo, successfully. So you can actually check the result from the previous runs. So you can find this from the Flyte side as well. You can see this is the second one. It's the run I completed this morning. You can check the time is 8:41 this morning. And you can see from here is 8:41. So this is the first job. And you can see this job is running on a spot instance because it's very small job. So it's running on very, I just give the very small like CPU memory. So it's run a micro, instance, right? It's on a spot instance. So, and from the wave watcher, you can see this one, you can see a very like how many memory is used. How many like CPU, how the CPU is used, and the network. If you have like external disks, we will show the performance and the utilization of disks as well. So, and this can be run on the spot instance. And if during the spot instance running, and if there's a decline happens, then we can use our like technology to float that job to another spot instance, right? So seamlessly. If the spot instance is not available at the moment, then you have the choice to choose to run that on demand as well to make sure the job is completed. So to start with the job, talk about something in the job here. So you can see this is same thing as we run that from command line. So that's the command line is built in with our agent. But I just want to quickly show you guys what's kind of like an option can pass to a job, right? So you have like you can choose the image here, which is we talk about. You can either from like a public repository, or you put in your private repository. and you can choose like you build the image yourself, or you can choose something you can get from like in the community. So then you can put a name here and job script or something. Then good thing about here, you can see for the instances, you can put like CPU or memory type or instance type. You can choose the specific instance to run your job, right? So you can define your storage configuration, and also you can, we talk about this, like you can choose spot first or spot only, or you choose the running on the on-demand, right? So another thing Jing talked about is wave riding. We call that migration. So you can enable to do the migration manually or automatically, right? Manually, basically, I'll show you an example a little bit later, how you can do that manually to make sure your resource allocation is defined well for the jobs, right? So here is like if you enable auto migration, then it can, based on CPU utilization, like upbound like 90%. If the CPU usage is reached 90%, then you can float, or low bound, like if you like the CPU utilization is very low, then you can float to a lower instance to save the cost, right? So also you can based on the memory, right? It's memory usage, and you can choose how do you want to migrate, like every time you jump like 50% or 100%. So this is the good feature Jing talked about with the wave riding, right? So now let's go back to the job here. So you can see the first one, the first step is already succeeded. So you can come to here, you can see the first one is succeeded and the second one is just started. So if you go to my, the AWS account, you can see a EC2 instance is started for the second step, right? So you can click here, you can see like the information here. And also for the first job is completed, you can go to this something like here, you can see the job. It's like this is the like some like results file is created here, right? So, and also while the job is running, so I can quickly show you something like a spot server feature. Let me try to find a job for you guys to see how we can quickly show you. Let me search a job. So you can see this job is showing like how spot server works in MMCloud. This one actually is running like I'm not sure if we have some like bioscientist here. This use like a star index application. So when you're trying to run that star index application, we start the job on a spot instance, right? So then spot instance get reclaimed, we float to another spot instances, and then it gets reclaimed again, and finally we float to an on-demand and make the job completed. So this is like if you check the job events here, so if you search for spot, you can see clearly there are two spot interruption happened. First time is happened on the spot instance and float to a spot instance, and not very soon, and we get the second spot interruption, and now we float to the on-demand. But the job itself, you can see, is complete successfully. There's no issue, even for this kind of like large instance here, like a 16 core, 128 gig bytes instance, the job still float successfully. So the job is running very well. This is how our spot surf works, right? So another thing I want to show you guys is like we can see maybe we can check for how the wave riding. I don't have.
Is there a space on the end at the end?
Huh? Oh, maybe
There's
space.
space at the end.
Oh, yeah. I see. Thanks. So you can see this job, right? It's the running on we are running on the Sentinel workflow. Like you can see at the beginning, actually the memory required for the job is very low. So we start with the small instances, right? So when go to the second job, and that process requires much larger memory. And so we go to allocate a large instance for that job, and the same for the third process. You can see because different process, they require different resources. So if you use without MMCloud, if you want to run the job successfully from the beginning to the end, you will over provision your resources for the job, right? So basically you have to take the largest requirement and allocate the instance, largest instance to complete the whole job. That will be very costly and very expensive, and obviously it's over provisioning, and you spend unnecessary the money for that. Or if you unprovision the instance, you use like a low memory, you might, when you go to the large instances, right, the large job, you might hit the out of memory error, and the job will fail. So, but with the MMCloud, obviously we can allocate different resources for different jobs, and you can see this is kind of like very successfully run. First job only require 2 core and 4 GB, right, memory for the job. But second one is like a 32 core and 64 GB, and the third job requires 48 core and 96 GB. So, like like I said, without the MMCloud, you have to provision 48 core 96 GB the virtual machine to complete the whole job, which is obviously very expensive. So MMCloud, we save the money. We also save the money to run this on spot instance. So that's a good example to show this thing. So I think the job is complete here. So let's go back to our demo, and you can see. So you can see all 3 steps, excuse me, completed successfully. And if you go to the graph here, you can see everything like get data, process data, and train model all ended successfully. So, and like I said, you can go to your S3 bucket to get your results. So I think I'm going to stop here, and this is the demo I'm doing. I did, and Jing, I pass back to you to see what else. Do we have more slides?
Sure. I see a raised hand. So maybe if there's anyone who wants to ask a question, let's take those.
Yep.
Keaton, please.
Yeah. Hey, the great demo. A quick question. So, do you allow reuse of a machine, or are you bringing up machines just dynamically, just like containers from?
Yeah, we bring up the instance for the job. When the job is completed, right, we just get rid of the instance. So, but you have the choice, right? If you want to run that, keep using the same machine, then probably you can actually we have the option to suspend the machine. So then you can reuse that. Let me quickly show you. I forget that. That's good.
Okay. All right. Let me get off the screen share again.
Yeah. Let's quickly show you, Kaden. So we have this really good feature, and I think I have to show this. Give me 1 second. So I have another job running on a different op center. This is actually the op center running on, you see, GCP. So we not only support AWS, we support the GCP, and we support some cloud in China, cloud service provider like AliCloud. So this is a multiple cloud platform. We actually, we hope in the future we can, utilize the resource across different clouds, but not yet. So here I have like jobs running. This is my job, Hui job. You see here, this is actually the Jupyter server. So I suspended that job for some time. Then if I want to, here is the Jupyter server. We bring up in the AWS, in the GCP. Sorry, right? So here. So I suspended this job. So that means if you don't want to use the instances in the, like, for example, overnight or over weekend, you want to, like, people take rest and don't use the Jupyter server, then you can suspend that job and basically without spending money. However, when you come back to work on Monday, you can resume that server and everybody can start to use that. So there's two ways. There's one way we have this built-in stuff here, so we can log into our cloud op center, and you see the status is suspended. You can resume the job from here. You can also go back to this job list, and you can resume job from here as well. Either way is okay. So if you you resume this job, basically, Keaton, it's not to use that spot instances. We create a new spot instance to continue the job, but our technology will keep the state of that instance. So the old state will be seamlessly migrated to the new instance. In that way, you don't lose the previous job, and you can continue, running the server. So which is a really good feature here. So you can see it's resuming and it's waiting for some time. It will take a couple of minutes. So, but it's just show you guys how this works. Yeah.
Like, I just had a quick question about the integration point with Flyte. Like, so when you started that job, you started it off really small and then it increased the resources as it went. Does your agent take the resolved parameters that the user specifies in like a Flyte decorator that says, I want this much memory and this much CPU? And then I noticed you had a list of different instance types ranging from like a C5 to like a T3A micro or something. Is that predetermined, or do you guys respect the resource request from Flyte when you generate that short list of potential instances to put the job on?
Yeah, there are two ways to do that. As I said, right? The manual way, there's an automate way, right? So if usually if you know how much the resources are required to run your job, you can predefine that. You can pass that parameter. Use some like a -C is for CPU, -M for memory. You can pass those parameters to your job. So when we launch the instance in the cloud, we will launch the instance based on your parameters. This is one way. The second way is we can enable auto migration. By auto migration, we will detect the real utilization of the resources. If the instance is too small to run your job, but we can auto migrate to a large instance. So, yeah.
Cool.
I have a couple of questions, Hui, but sorry, we don't have a hand to raise here in a meeting room. How does security work? Like, how do you run with the, I don't know, that's a service account or IAM role if you're running on AWS? How is that picked? And how do users define that? Who has access to pass on that role to the job that runs?
We run based on IAM, right? I think Frank maybe can help me to answer.
Yeah, you can define security group and the rules, and we obey all the rules defined for the MMCloud instance. And when you spin up a worker node, it will inherit the policy defined by the for the MMCloud, and you can specify like which availability zone and which subnet you want to spin up the worker node. So all those are within the AWS definitions.
So when you start the job, like when the agent and the Flyte agent starts the job for a task, it should pass in all the security like identities it needs. Is that the idea? I don't know if it's currently passing that or not, but that's the idea.
Yeah.
So there,
Yeah,
there
go ahead.
are some parameters here you can specify, but mostly it will inherit the security group you defined for the MMCloud instance. So
So there is just one role for the cloud instance that all the jobs will run as. By default, that's the model.
Yeah, by default it is, and also depend on what kind of job you'll be running. Like if it's like our studio, if it's our like some interactive tasks, then you can specify additional security group, and to allow those security firewall rules to be applied onto the new worker node. So there are flexibility to it too.
Okay,
Yeah,
so there's
just
some
to-
configuration in the operation center where you say if the job type is this, then apply these security
Yeah.
groups. Okay,
Yeah.
I see.
Yeah,
Yes.
we are also we are consider to enhance that even based on like a different like workload and the op center role separate this too. But that's we probably will do that in the future.
I see.
Yeah, we
Okay,
have this concept of the admin group managers and individual users that can all access what you see here, which is called the op center. And the memory machine op center would run inside the Flyte users, in this case AWS account, within their VPC. And then all the worker nodes that are spun up also reside within this network. And hopefully that helps to kind of better describe where we're running and also the security considerations based on that.
Yeah. Go ahead.
Yeah, and then the interaction point with the Flyte agent is through the CLI, or technically we have an API interface as well. So from there, we can launch the different worker nodes based on the different VM policies and parameters that are specified.
I see. Cool. Couple more questions. Sorry. I think it will be cool. I don't think the agents support that yet. If we specify, if like in the Flyte UI, there's a link that takes you to the job in MMCloud, and vice versa. There's capability in Flyte, but I don't think agents allow you to customize that just yet. Maybe something we can work on together. Because I noticed you were matching on like timestamp to find a job that was launched for a task, and on a large deployment that will be rather hard. So links will be nice. Can you? I don't know how proprietary. Last question. Sorry, I'll leave the mic after. Can you speak more about how the tech behind the capturing memory and moving it work? Like where do you store the state, or is that all proprietary?
You mean how we do this like floating, or like
the migration piece, like how does that work? How does that tech behind behind the scenes kind of thing, how does it work?
Oh, we have something called Apple Capsule. We have some like unique technology. So basically we take the snapshot of the memory and keep the system state of the job, and trying to, when you floating, then we kind of like float not only like the storage piece, also the memory piece, to make sure the state is kind of like is the same.
And it is stored in like S3 or something when you suspend a job?
We actually create the local data volume and we store that state in the we save in the local volume. Yeah. If you go to like the any instance, you can see we create extra like a volume we call float data. So we put the state there.
Sorry, where is that stored
In the
in
case
this
of
image?
in the case of AWS, it would be like an EBS volume that the
EBS
Okay.
one. Yeah, EBS one.
yes.
Oh,
So
that is automatically attached to all worker nodes.
Yes.
So they can
Yes.
spin up any of the existing suspended jobs. Okay,
That's right. That's right. Yeah.
I see. Okay, thank you.
Oh, there's one more question from you.
Jeev.
Hey, sorry. Yeah, thanks. My question was more around, your ability to support things like gang scheduling and stuff. If people are considering spinning up like Ray clusters or, Elastic like Torch clusters and whatnot. Is that currently a supported use case or on the roadmap or something?
Excuse me, is it what the cluster? I did not get Elastic. You mean Elastic Kubernetes cluster from the AWS?
Well,
That's
no. So like if I want to run a job and the job is a Ray job or some some distributed training job, for instance,
Yeah.
and I want something like 5 instances or 5 nodes to be up before I can run my job.
Yes.
Like that typically requires things like gang scheduling and stuff. Is that something that like MMCloud currently supports, or is it just like a single node per job type situation?
We don't do it by ourselves, right? We leave to the like I assume that's for example the workflow manager, right? I leave this to Flyte or Nextflow or this kind of things we don't take care of. We kind of like a bunch job launcher. So whatever the manager pass the job to us, we launch in the cloud and make sure it's running on the. We can run on spot instances or on demand. We make sure the job is completed successfully. Regarding the sequential, this kind of order of the jobs, we leave this to, we don't manage that by ourselves.
Got it. Thank you.
Yeah.
So we have
maybe a follow-up question real quick.
Oh, okay. I just wanted to say just one thing adding to Hui's response was we have a project with Ray. It's focused on solving a slightly different set of issues. But essentially, it would to work where you can launch like a Ray cluster and then have some of these benefits of memory machine cloud. I think it requires a little bit of disassembling some of the layers that we built, which we do have a version of that running for Kubernetes. So it's not as tight of it's not this tightly, more opinionated way of using us, but it is something that we can support. So we just encourage people to reach out if that's of interest.
Got it. And so I think that falls then, the same answer would be for workflow preemption on array cluster, that you leave this up to the orchestrator to figure out what's higher priority, lower priority. Is that correct?
Yes.
Okay,
Yeah. So we would
thanks.
have to, this would be like maybe it's a separate project that we look at working with the Ray community to enable.
Okay, thanks.
Yeah, I also had a question. I see that for every task, users had to define an MMCloud config task config. What's that exactly? What do they need to put in the config?
Let me quickly show you some like share some configuration here. Oh, so yeah.
David,
okay,
some of it is also for Flyte to identify that this job has to be run on MMCloud, right?
Yeah.
Like
so
Flyte has some need of identification.
Exactly. So you need for example, you need this is the one example file in the YAML file. So you need to enable the agent service right? So what's task, MMCloud task, we are calling this agent service. And here in the plugins, you define the agent service, like what's the endpoint. Obviously, we are running in the local host, so we use this like 127.0.0.1, right? So which port your agent is served on, right? So also like MMCloud, make sure MMCloud task, we call MMCloud agent, right? So also another thing we defined here is kind of like we define the storage. You need to, I know like we use this like sandbox Flyte provided, which also have the MinIO object storage built in. You can use that for the simple job, but for the large job, you want to use your own S3 like the storage. Like you see here, we config some like storage thing there. Yeah. So this is the configuration you need to pass to your MLCloud. We have another thing we can config. I think that's we develop. We can pass some like a CPU requirement or the memory requirement. But in this example, we did not use that.
Thank you.
Yeah.
Right. Awesome. I think you have any other content to share?
So I just want to say that the slides that we presented, along with probably the last slide, which has some useful links for people, we're happy to share that out. We'll take your lead, David, on the best way to send it out. Maybe we can email it to like all the registered attendees or some other listserv that you have. But this is really the last slide. So we just wanted to highlight the architecture of how we work once Flyte has sent us tasks. And then, if you want to get started, if you want to read more, get access to the docs, these are the links.
Oh, that was great. Thank you so much. And sorry for overwhelming you with questions.
No, that's great.
No, that's good. Yeah, all good, all
so
good
interested.
questions. Yeah.
Awesome. All right. Yeah, we are past time. Anything else? Any other question?
Thanks for having us on this time.
No,
Yes.
thanks again, Yi, Hui, and the rest of the Memverge team. It was great, and we hope to keep collaborating. And thank you all for joining.
Yeah. Thanks, everybody.
Thank you.
Thanks.
Thanks, everyone.
Yeah.
Yeah. Yeah. Bye.
Okay, bye.